In this class, let us learn about dielectrics. Dielectrics are non-conducting substances or insulators. They have no charge carriers. They are of two types, polar dielectric and non-polar dielectric. A polar dielectric consists of polar molecules in which the centers of positive and negative charges are separated by a small distance. For example, hydrogen chloride molecule. Hydrogen atom is slightly positive while chlorine atom is slightly negative. So the molecule has a permanent dipole moment. Another example is water molecule. A nonpolar dielectric consists of nonpolar molecules in which the centers of positive and negative charges coincide. So the net dipole moment is zero. Example, hydrogen molecule. Another example, carbon dioxide molecule. But if you consider the substance as a whole, the dipole moment is zero in the case of a polar dielectric, as the dipoles get randomly oriented. The net dipole moment is zero. In the case of nonpolar dielectric, the dipole moment is zero because the molecules do not have dipole moment. But let us consider the dielectric when kept in an external electric field. In the case of polar dielectric, the dipoles get aligned in the direction of external field and thus develops a dipole moment in the direction of external field. In the case of nonpolar dielectric, the molecule becomes a dipole as the centers of positive and negative charges get displaced. So the substance develops a dipole moment in the direction of field. So both polar and non-polar dielectric develops a dipole moment in an external field and the dielectric is said to be polarized. But inside the dielectric, the net charge is zero, as the positive charge of one dipole lies close to the negative charge of a nearby dipole. But on the surfaces normal to the electric field, there is a charge density, a positive surface charge density on one surface and a negative surface charge density on the other surface. Due to the surface charge density, an electric field is produced which opposes the external electric field. So the net electric field in the dielectric is reduced. It is E0 minus EP. E0 is the external field and EP is the electric field produced due to polarization. The polarization may be defined as the process in which a dielectric develops a net dipole moment in the presence of an external field. It is the dipole moment per unit volume. Polarization P is directly proportional to the electric field. The resultant electric field E is equal to E0 minus EP. E0 is the external field and EP is the field produced due to polarization. So P is equal to the constant chi into E. Chi is called electric susceptibility of the medium. The extent of polarization depends on the potential energy of the dipole in the electric field. which tends to align the dipoles in the direction of field. It also depends on thermal energy, which tends to disturb the alignment. The resultant electric field in the dielectric is reduced due to polarization. So a dielectric may be defined as an insulator which can be polarized. Example, glass, water, air, wood, etc. Now let us define the dielectric constant and dielectric strength of a medium. The dielectric constant is defined as the ratio of external electric field to the resultant field in the dielectric, denoted by K is equal to E0 by E. E0 is the applied electric field and E is the resultant field. It is equal to epsilon by epsilon 0, where epsilon is the permittivity of the medium and epsilon 0 is the permittivity of free space. A dielectric strength is defined as the maximum electric field that a medium can withstand without the breakdown of its insulating property. A high electric field ionizes the atoms of the insulator and it behaves as a conductor. So there is a limit for the electric field that can be applied to a dielectric medium. Now let's see the difference in the behavior of conductor and dielectric in an external electric field. In the case of conductor, the free electrons would experience a force and the free electrons would drift opposite to the external field. And thus the surfaces attain charge densities positive on one surface and negative on the other side. And it produces an electric field which is equal and opposite to the external field. So the net electric field is 0. In the case of dielectric, due to polarization, the surface charge densities are developed on both surfaces and it produces an electric field which is opposite to the external field. But it is less in magnitude, so the resultant field is non-zero in the case of dielectric. Thank you.